we do have people that are like newer in the industry that listen to the podcast. I mean, do you want to describe a little bit about, memory safe versus memory unsafe and sort of what we've seen like C++ versus maybe Rust,
Yeah.
something like that?
Yeah. So C, C++. So when we talk about memory unsafe languages, uh, those are languages that allow the programmer to actually address objects in memory directly, right? So, typically, you have the ability to declare a variable, and you're kind of putting me on the spot, so I'll wing it here, right? But in any programming language, you have the ability to declare a variable and assign some sort of value to that variable, right? So I've got a name, and that name is spelled out somewhere. I reference the name itself, and I get the value back out of memory of whatever I specified to that, right? Memory safe languages do not allow you to directly access the pointers in memory that point to that value, right? They handle that for you, is what it boils down to. Whereas C and C++ has the ability to actually directly access the pointer to that value in memory, and adjust that pointer to do things with the pointer. And so when that happens, there are all sorts of classes of vulnerabilities that exist because of that, right? Like I can change that pointer value and see what else is in memory, right? I can directly address it and see, hey, maybe there's a value like someone's credit card number that is in the pointer value that's directly before mine or after mine. And there's techniques that attackers use to actually comb through the memory to do malicious things, to cause crashes. And then when we start to talk about memory in general, part of that are instructions that are used by the CPU that are ordered in a specific manner. So if I can overwrite the value of my name that's been specified as 5 bytes or whatever it is, and I can overwrite that with 20 bytes, I may be actually able to overwrite instruction pointers that the CPU is going to execute next. And that's where we get some of these exploits that happen. So the topic of memory safetiness directly applies to the security of the underlying chip and operating system and what you're able to access from a data perspective and an instruction perspective on what the CPU is doing. Because C and C++ are so low level, they allow us that access to memory. And I'm not getting into all of the specifics of heap-based overflows versus stack overflows, where that comes into play, like the instruction sets, right? Like there's a lot that goes into that. I'm just trying to very quickly summarize what a memory safe language is, right? Memory safe language abstracts out the ability, or it prevents the developer from accessing those memory objects directly. That's really what it boils down to. Does that make sense, Ken?
Yeah, take
Yeah.
out the human error, allow the language to perform that collection itself and clean things up itself.
Mm-hmm. Yep.
And to be fair, I will say this though. Back in, I mean, I can't remember, but we'll say early 2000s for me, anyways. And you may have a different viewpoint. When memory safe languages started to come out on the rise, we were all pretty relieved, and that was really, really nice. And felt like we could start to focus on different types of security issues. I don't know if that's how you felt. So back then, this was really like 20 years ago. This is pretty neat stuff. And I realize, like I don't know if today this is still the case, but I do realize, like, when you and I were doing C++ reviews, it was like powering, cashier, gas pump stuff, like all kinds of different, systems. So it's not to say that this isn't like a legitimate thing with, yeah, with products today, I just mean that I like this as somebody who is highly invested in bringing forth a new way to perform software security analysis using artificial intelligence. It is cool for them to keep mentioning over and over again that there are new, that it will help with folks who are doing things like that to reduce software security issues. You know, pushing. They
Yeah.
keep saying things like pushing the frontier on new foundational technologies, and I think they're just hinting. I think they're saying what they don't want to say out loud, which is like, yeah, and it maybe other techniques that they're talking about too. I'm sure, but for sure, like AI is on top of mind for some of these bits, but for
Yeah.
probabilistic
I mean,
analysis is really
yeah, it
what it
has to
is.
be, right? Like, yeah, I
Yeah.
mean, it's AI, it's artificial intelligence, whatever that actually looks like if you're using one of the, LLMs, but, or it could be any other machine learning technique for identifying algorithms and identifying, this space. This is part of what I really appreciated about the article is they talk about, okay, so they've got a specific problem that they're trying to address, memory safe vulnerabilities. How do we go about that, right? Number one is, okay, we know we've got this stuff that the computer science nerds, right, like I include myself in that, have done for a number of years, and they've talked about formal methods. That's great, but to your point, Ken, like that doesn't necessarily happen in the commercial space with the other the with the other pressures that exist when I'm trying to develop software, right? Formal methods can go out the window just because it's more difficult to put something that into play, and it takes longer, and it maybe ends up costing more. So, you know, we have to have a way to actually measure that. So there's a weakness here that we have as well in actually, measuring the safety and security of our code. Yes, we do pen testing. Yes, we do, QA testing, but a lot of times that is insufficient. This goes back to other issues that we've talked about in the past. Again, this is where like my Crocs and socks starts to come out, right? Like unit testing, like full coverage, code coverage. We just don't, like, we're very immature when it comes to that. In most spaces. Now, that doesn't mean all organizations are immature, but we don't necessarily have a good way of measuring how secure a library is and whether or not it is coming from where we expected it to come, right? Yeah, so that's the quality perspective that they're talking about here, specifically around Log4j. They bring that up. They're saying that the market is getting better about cybersecurity, which I would agree. And part of that is this shift in responsibility, like who's responsible for cybersecurity quality in code. Is it the CISO? Because that's what it's traditionally been, right? Is it the CISO? Is it the CTO? Is it the CIO? I mean, the organization at large, it is responsible for the code that it produces. But traditionally, we've looked at the CISO as the person that controls the cybersecurity compliance needs, where the CTO is the one that's actually generating all of the code from that organization. And so there's been a disconnect, and that's where they're calling this out as actually getting better.
I do think it's, zooming out from all of it. Really, it's nice that the White House is putting out some
Yeah,
thoughts on software security and making it a priority. I think it's important.
Yep. And this is
So
why
that's
you
nice.
should take our course,
Positive.
right? The challenge of eliminating entire classes of software vulnerabilities is an urgent and complex problem. You want to know how to actually take care of it, right? Yeah. Come to us, right?
you know,
Yeah. Yeah.
honestly, I can't wait to show some people how to use LLMs, because, like, and this is not a knock. I mean, it's really neat that some security researchers have put out, like, here's some prompts or some tools to throw some code at. Usually, almost always it's OpenAI, right?
Yeah.
And that's all neat and everything. The reality is, though, is as soon as you start actually getting into the weeds with it, you're like, oh yeah, like you can't do that. And obviously, like OpenAI also has its own concerns, but in terms of just effectiveness, it's cool for like a gimmicky, like, one off. But when you're trying to do this at scale with many languages and whatnot, it's not as easy as that. But what is nice is that you can use LLMs to do compositional analysis and break out key markers. And you can do that with your own private LLM locally on your machine, assuming it's modern.
Mhm.
So, anyways, I'm excited to show people how to quickly understand the composition of an application using LLMs.
A couple of housekeeping items before we, kind of launch into the next topic, though, Ken. I posted the article to Smashing the Stack by Aleph One. This was the seminal memory safe exploit, right? Like unsafe exploit for stack overflows, right? From years ago. You can't necessarily do this anymore because the compilers and some of the newer chips aren't actually vulnerable to stack smashing anymore, but it is a great place to start if you want to understand um, stack overflows and why unsafe languages are so dangerous and why they have been over the years.